Okay. I can't even tell if this is recording or not. There we go. I think it's going. I think it's going. We got one person. Let's get in here. Jump in, say what's up, say hi. Excited for people to be in here. Let's see. That's that one. And just this. A little bit. All right. We've got 3 people in here. What's going on, everybody? This is the second installment of forging a Wariha Tetsu Damascus pattern. Matthew Fusco 3844, what's up? Thank you so much for jumping in here. All right, so Rick Allen's back at the house. Hello, sir. Okay, I got my steel. It's hanging out in the forge. It's roasting. Let's see. I haven't checked my timer in a minute. Let's see what the timer says. 7 minutes. That's great. Time has flown by. I don't know about you guys, but steel's been sitting in the forge, hovering at about 2,000 degrees, just sitting there soaking. This process is referred to amongst a small group of makers, Damascus makers, as aging the weld. So this is essentially giving that weld that we just established on that in the last video, at the end of the last video. We set the forge weld, giving that weld time to age, to mature, to ripen, whatever you want to call it. But it gives time for the material, the individual pieces. We'll use these as an example. We have all these individual pieces. Now, they are touching when you put them in a stack like this, but there's actually still tiny little gaps in there. Let's see if you can see the gaps. The light through. Yeah, you can see the light through the stack, right? So, when we set the weld, the pieces are brought up to temperature, you smush them, and it allows them to, or it encourages them to be touching, not just at a physical level like that, but at an atomic level, so that the pieces are so close at such a high temperature that they start trading atoms across the boundaries of each individual piece to create a homogeneous bond, to create a homogeneous material through a process called diffusion welded bonding. And so, after establishing that initial weld, I have now been aging that weld for the last 20 some odd minutes, and 24 minutes. And that is giving the steel time to trade those atoms, to help strengthen and ripen those bonds. Now, it could be good, could not be good, I don't know. The strength of those bonds is the bigger concern. So you can establish a bond, but how strong of a weld that is yet to be determined. So I'm gonna go through and reduce it down actually a bit farther. Probably gonna take it down just another 1/2 inch. And actually before I do that, I just realized I can crank that temp up just a little bit. So I'm gonna pull you guys over here so you can watch that flame as I turn the gas up. Right now I'm running at 15 PSI. I'm pull it up to 25. I'm going to tune this so it's less, so this is very fuel rich. So fuel that the excess fuel has to leave the chamber of the forge to ignite and burn. I'm going to allow it to shoot down the barrel of this burner so that is drawing more air with it so that it burns more lead. Now it doesn't have to be crazy, but I do like it soft like that. Now there's a lot of heat coming off the back of this forge. I'm trying to adjust that so that I'm not burning my hand off and also not burning the burner. Okay, so what's interesting is the flame that the camera is picking up. So there's a very lean flame. Neutral. That's fuel rich. You also hear the difference. It sounds, when it's running lean, it's drawing more air, it sounds more ragged, versus less air, more fuel, it's a little softer. Ragged, neutral, lean, and now it's richer. This is too rich. Again, I don't need it that much flame coming out. This is good for me right here. In fact, I'll call it good right there. Cool. So, that is also going to bump the temperature of my forge up at least a couple hundred degrees. Not only the extra fuel will do that, but running a little bit leaner of a flame is going to bump up the heat. So, while that finishes its soak, Hidden Horse Forge, what's up? Or Hidden Rose Forge. I'm classically known for messing up everybody's name. Anyways, unless I know you, like Rick. I know you, I'm not gonna mess it up. But I probably actually still might mess it up. Anyhow, a couple more minutes, then we're gonna get it, we're gonna pull it out of the forge, we're gonna set that weld, and I'm gonna reduce it down probably only by about 1/2 inch again. That first round, I guess I did reduce it by about 1/2 inch. Good morning. I reduced it by 1/2 inch in the first round from 2 1/4 to about 1 3/4. So now I'm gonna pull it down a little bit more to about 1 1/4. And then we're gonna put it back in the forge. By that time, I'm still kind of babying the weld. I'm gonna what I do is, what I refer to is massaging the billet. So I'm not gonna jam down and smash it right down to the dimension I want. I could definitely do that with this heat and with the force that I have coming off the press. But I want to gently massage it down. I want to slowly work it down. So I'm gonna take my time, massage the billet out down to that 1 1/4 inch. Again, taking small bites. About 1/8 of an inch depth bites. Craig J 333, what's up? I'm gonna rotate this little marshmallow real quick. That way it's heating up nice and evenly. And then I'll put it back in the forge. And then I'm done with hot or long soaks at that point. Unless something terrible happens, I'll be done with long soaks. It's just about getting that steel back up to temperature again for me, so that I can then start working again. So I'm gonna work it down to a 1 inch by 1 inch square stock, so that I can incorporate it with some 1 inch by 1 inch 1080 square stock that I have already. And then, that's it. I think I've explained enough. So, if anybody's got any questions along the way, along the process, the sounds you're hearing, I will say that this is a loud process, which is why I have earbuds to help block out some of that sound. So if you're somewhere that needs to be quiet, baby's sleeping, you're at work, wherever you're at, you probably want to turn the volume down, especially once I turn on this press. And yeah, but I think we're just about there. Let's see. Yep, did it. Perfect timing. Okay, I'm gonna move you guys over here. This way you get a little bit of both the forge and the press. Actually, I'm gonna do this so you can get a little bit more of a side view, so you can see the material get smushed down. I also need to grab my eye protection. this baby off. Everything is holding together beautifully. I'm gonna get it back to the floor. Okay, so basically, I want to be, even though I have established that forge weld, again, the question is how strong is that weld, at least in my mind. I've never really done the destructive testing on what it takes to pull that material apart. I'm sure that would be a very interesting video. I've just never taken the time to do that, so, but that's something to think about for the future. Anyways, so it was about, what was it, 1 3/4 inches tall. I reduced it down to roughly 1 1/4 inches tall. But like I said, I massage it by only taking small bites. You also may have noticed that I'm not doing full face bites of the forging dies. I'm only using maybe a 1/2 inch or 1 inch to start, and then moving in small incremental bites, about 1/2 inch bites. So I start with 1 inch at the end of the billet, squish it just a little bit, about 1/8 of an inch, and then move that billet onto a new part of the billet onto the die for another 1/8 inch bite, and then another 1/2 inch, 1/8 inch bite, and then another 1/2 inch, 1/8 inch bite, and I do that through the whole length. Flip it over, do the same thing, flip it over, and I just keep doing that while it's hot, but only while it's hot. Now, it's definitely, at least, especially in regards or in terms of heat for ourselves as human beings, that steel's insanely hot. But in regards to the amount of force that we're using and the process that we're going through right now, when the steel gets too cold, it can start, especially under high pressure and high force, whether it's under the hydraulic press or under a power hammer, that force can start to tear that material apart if that weld doesn't have a lot of strength. So again, we're putting it back in here to not necessarily age the weld, but really, hopefully, the aging we did after the first round of welding, it's done its job, and it's holding everything together. It looks great. It looks very solid. I also, as you probably noticed, I like to try to keep the billet as clean as possible throughout the whole process, whether I'm scraping it off on the forging dies or brushing it off with my grill brush, which is worse for the wear, I'll tell you what. This thing needs to be replaced. But anyhow, I try to keep the billet clean. I'm gonna flip this over real quick. And I'm just gonna start working it again once it's back up to temperature, nice hot temperature, matching the forge. The forge is probably running it, like I said, about 2200 degrees. I'm good with that. I like that temperature. It's not too aggressive. And so, yeah. So, if anybody's got questions, please feel free to jump in. Oh yeah, I think somebody over on the Patreon actually had a question. Let's pull them up. Awesome. Won't be able to watch live, but we'll definitely watch the recording. Okay, Evan Davis, hell yeah, words. Tetsu. Wariha, Tetsu, and Rick Elm. Thumbs up. Thank you, Rick. I appreciate everybody's positive support. Okay, I think that's it for now. So, again, if anybody's got any questions, feel free to ask about anything. It's kind of an AMA opportunity as well. Not only are you hanging out with me while I forge, AMA, steel's getting pretty close to a good temperature. I'm gonna flip it one last time, and then we're gonna go back under the press, okay? When you get under the press, we're gonna reduce it just a little bit further, and I'm actually gonna put 1-inch stop blocks underneath. And then we're gonna start working along the edge of the die, or of the billet. I need to double check though, which of my spacers is my 1-inch spacer. That's where these come in handy. Let's see what we got here. This is 1-inch. Perfect. I got my 1-inch spacer right there. Let's check this one. Let's see where this one's at. That one is exactly 1-inch. So we're probably gonna actually use this one as 1-inch spacer. If I'm not mistaken, I think this is just, I can't remember if this is mild or if this is carbon steel. I have a tendency to use Damascus scraps, or not scraps, but just chunks of Damascus. You can maybe see the pattern. I'm not sure. Let's see. I'm not sure if it'll zoom in or focus on that or not. Anyways, it won't. Anyways, there's Damascus in this, but this is also 1-inch chunk of mild steel or carbon steel, whatever it is. I'm gonna use it. We're reducing this bar down. Look, temperature looks good. Get in here again. I'm zooming in because I don't want my camera too close, my phone too close, but I also want you to be able to see what's going on. Working on the edges, so I'm going to get it back in the forge and heat it back up. We're going to add a little spacer. Where is that little spacer? I have a tiny shim spacer. Must be on the ground somewhere, I don't know. Oh crap. You know what I just realized? I forgot. This is classic for me. So far, excuse me. So far, last time I did a live stream, I made mistakes, and this time, I also made mistakes. So, I'm not quite sure what to do about this. Because I was meaning, before I got too far, before I got to that 1-inch size, I was gonna forge it on the bias. I even had it drawn out right here, right? And I completely forgot about that, which messes up this pattern. Now, I'm trying to decide what I should do, because now that it's this thin, it's hard to do the forging on the bias, and it doesn't make sense to cool it, cut it, stack it, try again. It's going to refine the lines too fine. I don't want that. So, I think, damn it, I'm frustrated. Damn. Try not to be too pissed right now. Every time I do a live stream, I fuck something up. Okay, so, this plan is no longer viable. So I think what my plan is going to be now is to just, let's see, this is 9 pieces. 15 times 9. Let's see. I'm going to do some quick math. So our original stack, the gradient stack, had 12 alternating colors in it. Oops. 12. And then restacked it to create a billet with 13 lines, and then times 9. That's still 1,400 layers. All right, so we're about, it's going to present as around 145 layers, 140 layers. But the reality is that it's, I lost it already. 1,400 layers, 140 layers. It's gonna, anyways. So, we're just gonna make random pattern material out of this. I'm sorry, that's not very interesting. It's kind of boring, but I totally fucked up. And so, this is why you got to be able to pivot. Damn. Thankfully, I do have more material, but it's going to take time to reduce that material down and turn it into something interesting so that we can come back and do this. What I really liked about trying to do this approach is that with that Wariha Tetsu, there are potentially 5 different style of knives that you can make with that 1 bar of steel. So you get the pattern to present 5 different ways just with the 1 bar, which I thought was going to be really cool, but I screwed it up. I'm trying to think if there's a way. No, I don't think there is. There is not a way to try to salvage this right now, because I told it I needed to forge it on the bias. On that last round, actually, I needed to true up the edges and then forge it on the bias, but I completely forgot to forge it on the bias, and I just smashed it down to 1 inch, which is not helpful. So I guess you're just gonna hang out while I forge it out to bar stock. That can become that can then get forged into knives. Okay. Try to laugh about it. It's not that funny, but I'm trying to laugh about it. Let's see. Actually, I'm getting ahead of myself. I need to rotate the fillet. And then we'll pull it out and forge it one more time. I think we got some questions here. Where do you purchase your 1-inch square stock? So I got my 1-inch square stock from Kelly Couples, who's based out of Yakima, Washington. But I think there are different people that sell 1-inch. I think actually, Maritime. Our friend Lawrence Lake over at Maritime Knife Supply, he actually sells 1-inch stock. Now, if he doesn't have it in square bar, Rick, I know you have a forge and I know you have a hammer. You can forge it down to square bar. Another way to create square stock is to just weld material back to itself. So I have a stack of these 1080 plates, right? I've done this before. Take a bunch of individual plates, all of the same material, this is all 1080, weld it up, draw it down, and then you have square stock. So you can buy it if you want, or you can use the stuff you got. So, it is possible to twist the material from here. I don't know though, the layers are super tight, so I don't know if it would actually look very good. I wouldn't be very interested in a tight layer twist like that, I don't know. 150 layer twist. Also, I don't really enjoy twists because Bob Gore in the house, what's up, brother? I don't enjoy twists, at least making them myself personally. I like seeing people make twists, but I hate making it myself because I feel like it's a waste of material because you gotta cut away or grind away a bunch of material. And like the pattern on the outside can be somewhat interesting, but the real good stuff is down in the core in the middle. And if you're gonna get down there, you gotta waste away a lot of material, which is kind of a bummer. So, yeah. All right, I'm gonna pull that steel out. I'm gonna forge it down. I don't need that 1-inch spacer anymore. I probably am gonna forge the bar down though to about 1.25 inches. Sorry, I lost track of my calipers. 1.25 inches, 1.5 inches. 1.5 inches. This is my inch. 1.25 inches. Bit of extra material, and then that will be material that I can forge into a chef's knife. Okay. So it'll be 1.25 inches by 5/8 is what I'm going to forge it down to. Again, let's zoom in here. Everything looking nice and tight and clean. That means to me that our weld that we aged was very solid. So I'm just gonna keep reducing it down. Here we go. I'm gonna continue. Whoop, get out of there. I'm gonna continue out height-wise before going back to actually, I'm trying to decide what makes the most sense. Yeah, I'm gonna keep reducing it down height-wise, and then I'm gonna go back to the faces, because what I want to do is I want to figure out the balance. Sorry, it took me a second to figure that out. I'm trying to figure out. I really like ending with forging on the edge, because if you saw in that last round, that forge scale pops off really nice and cleanly, right? So I like doing the last bit of major reduction in the height across the width. Across the width on the edge to pop that scale off, and then I'll work at cooler temperatures just to flatten that bar back out. And I'll basically do planishing compressions. Still hot enough to forge it, but not so hot that it's creating a lot of forge scale, and not soaking it so long that it's creating a lot of forge scale. That way I have a thin forge scale layer on it. Now that's, I guess, more of a priority when I'm getting ready to clean a billet, restack it. What I'm going to do with this material is just going to cut off a chunk and forge a blade out of it. Damn it. I'm so annoyed that I did that. I'm so annoyed. What can you do? I really don't know. I don't know what you can do. Just try to learn from it and move on. Anyways, steel's getting back up the temperature pretty quick, which is nice. As the material gets thinner in cross section, it is going to heat up faster. So that is definitely something to keep in consideration when you are forging your material out. So I'm going to finish forging at the width, then I'm going to forge across the face, and then I'm going to go back to the width. Oh wait. No, yeah. No, I want to forge on the faces this time around. Forge on the faces to get it down closer to that 5/8 thickness. Which means I got to find my 5/8 spacer. Grab these calipers again. Let's see, what's this? That's it. 5/8 right there. Okay. So forge across the faces to reduce it to the 5/8. Right now, it's still at like an inch, just fat of an inch, inch and an eighth. So I have a bit of reduction to do across the faces. Then I'll turn it back to the edges, finish with the edges, pop that thick forge scale off, and then use planishing compression to flatten that out, finish drawing that billet out, and then we'll be good to go. Okay. Billet's nice and hot. Let's swap this spacer out. Oh. I know I'm touching things with my bare hands, but you do want to be careful. Anything that's near the steel or touching the billet, that billet is radiating a ton of heat, and it would be very easy to accidentally burn yourself because of the amount of heat that it gets transferred into the forging dies as well as the spacer material. So at a certain point, I gotta try to be a little bit more careful not to touch things that are probably very, very hot. I'm gonna do something a little bit different this time. So when I was initially drawing out the billet, I was using small bites. I was massaging the billet. Now I'm gonna use full face compressions intentionally to encourage the way the billet is moving. Okay. So, I know, I just realized what I said. I said to encourage the way it's moving. That's not very informative as to what is happening. So, when you take small bites and you massage the billet out, the billet moves more longitudinally, which is down the length of the billet. But when you do bigger full face bites, compressions, then it'll move a little bit longitudinally, but it'll also move quite a bit transversely across the width of the billet. And so I was trying to encourage movement across the width on that last one. And so now I'm going to bring it back up to temperature, and then I'm going to go back under, and I am going to do I thought I was going to do 1¼ inch height. I'm going to do the 1½ inch height. Just makes it easier, especially when I'm forging my integral chef's knives. It makes it easier to have enough height already to then pull down a heel that is 2¼ inches tall. So rather than having to pull it down from 1¼ inch to 2¼ inch, a full inch, I'm pulling it from 1½ inches to 2¼ which is 3/4 of an inch. Just that little 3/4 of an inch makes a huge difference in the ability to pull the heel down. It also affects the overall forging progression. When you have to do a lot of work to pull the heel down, you can cause a lot of wonky things to happen in your material. It's not ideal. So, let's see what's going on next. So I'm bringing up to high temperature. I'm going to adjust the height over here. Let's see. So I'm going to keep the 5/8. Set that aside. I'm done with the 1¼ and I want the 1½. The 1½, which is actually cold. I don't know why I'm using the tongs. The dies are very hot. Found that out. On reducing the height down to 1½ inches, and actually I'm not going to use that shim. I decided I don't need it, so I'm going to reduce it down to 1½ inches, and then so I'll pop off the forge scales on the faces. I gotta say it. Finish on the faces of the billet. So when you're trying to get the scale to pop off any surface, the more that the die is engaged, the more of the surface you're gonna be compressing all at once, or the more of the forge scale you're gonna be upsetting all at once. And so I'm gonna probably do basically full face compressions again. Full face meaning the full length of the face, the depth of the die face, so that I'm getting that scale to pop off. I'm going to lower this down just a little bit. Try to... I want to try to zoom this in for you guys so you can really see what I'm saying, get a better idea of what's going on. All right. All right, so I got my height, and the face is very nice and clean. I'm actually going to reduce the temperature down on the forge. Quite a bit. I don't need it that hot anymore. I'm not trying to weld it, and I'm not trying to do any like crazy reduction in forging. Now I'm just doing light blows. It's already hot again. Just wanted to get it brushed off. I need to get my 5/8 spacer in there, and I start compressing those faces again. Faces of the steel are very clean. Here, zoom in actually quite a bit, so you can kind of get a better look at that. But the edges, as you can see, there's forge scale along those. I'm going to brush that off. Then we'll go one more heat just to straighten things out. Often in the forging, it doesn't matter if you're using a press or a power hammer. The billet always ends up just a little bit curved because one side of the die compresses a little bit more than the other. So instead of 6 knives, we'll probably be able to get 4 knives out of this billet. Let's see. We're back here. I'm going to put my straightening dies on. So, I have a long die for the bottom. Top die, or long die for the top. I'm going to straighten it along the length first for the height, and then I'll straighten it across the face. And we'll be done. All right. Now I'm gonna put it back in the forge to normalize the billet. This will allow me to cut the billet down. Now, I don't do anything too crazy to normalize. In fact, what I am going to do is only do half of it at a time. Call that half, that balance point there. Great. So we'll just do half at a time. But this way, again, it helps to make it so I can cut the steel on my bandsaw very easily. If you were watching the first video, you saw how quickly I was able to rip through that material. Same situation. The way I do it is I basically bring it up to 2,000 degrees, or I don't know. It's definitely austenitized, but what I'm trying to do is I'm trying to think what structure it would create. Probably creates coarse perlite because of how slowly it's cooling, and that allows me, it allows the material not necessarily to be soft, but the structure allows it to be tooled more readily. So either drilling, cutting, whatever. So I want to use a bandsaw on it, right? And so I'm going to do this process, and I'll be able to cut it on the bandsaw. Let's see. We got a question here from McCollister. It says, is that glass or metal? It is metal, sir. McCollister. I don't know if you're a sir or not. Apologize for that. Is it cool of you to be sharing so much? Or it is so cool of you to be sharing. Yeah, you're welcome, Bob. Yeah, I'm here to help. Let's see how this is looking. All right, so I'm gonna pop that in just for a second. I'm gonna turn the camera so you can see where that steel is at. So this temperature looks great to me. So I'm actually going to turn this around now. Put the other end in there. Do it again. You can see the pattern revealing itself on the surface of the steel, which is pretty cool, I would say. I like it at least. You can even kind of see how that gradient is blending. But anyways, the other half is going to come up to temp, and then we'll call it good. We'll let it air cool, and then once it's nice and cold, I'll be able to cut a chunk off and forge a knife out of it. Man, so frustrated. I think what I need to do in the future, I have this whole garage door here, right? I need to write out my plan and then stick it on the door so I can just look at it all the time. Or even put it on the tripod. I feel like putting it on a tripod could be a problem, but somewhere where I can see it all the time so I don't forget what I'm supposed to be doing. Because so far, I've done that multiple times. We'll see. I might get there someday, guys. Who knows? Who knows? Let's see. Yeah. Otherwise, and honestly, sometimes, depending on what I got going on or what kind of rush I'm in, I sometimes I'll pull it out, and instead of just letting it air cool, I will actually I will put a fan on it to speed up the cooling process. but that doesn't affect its ability to be cut on a bandsaw. I can still rip it down on a bandsaw just fine. So this other half is looking pretty good. Anyhowsies. I'm trying to think. What is this chunk of steel? I got chunks of steel laying all over. Something that's been forged on the bias. What it is, I do not know. I'll have to, I don't know. I'll have to have a look. It is not a gradient, unfortunately. I can tell that already. But what it is, I don't know. Should probably put that somewhere handy though. What's this chunk of steel? This was reverse C's. I should write that on here. Reverse C's. And then after this video, I think it's going to be time for lunch. So, I'm trying to think if there's anything else useful to you guys to actually see me doing. I don't know. Alright, this side's hot. I think I'm going to flip it. The other side just one last time, just for good measure. Why not? I got time. And I'm not cooking it. At a low temperature like this, I'm not cooking the steel. I'm not cooking the carbon out of the steel. I'm good. So, I am going to do that again. Well, not make that mistake, but make that steel again. I just need to keep track of what the hell I'm doing. I have bars of steel laying all over the place on this thing. Thankfully, I label most of them, but sometimes I forget to label them. And I don't know what the hell I got. I do have, oh shit, dropped my pen. I do have this gradient. Part of me is tempted, oh god, but drawing this out is gonna take a lot of time, which is not very interesting to watch. But anyways, what I'll probably do is draw out this gradient into a bar, cut it, restack it. We're going to do a redo. A little bit of a redo. And yeah. So frustrating. Anyways. It looks like we got another question here. Oh, got some steel slivers in my hand. That's cool. Par for the course. Is there any issue with using MIG welder instead of a TIG welder on this process? Not on this process because I'm just doing a regular restack rig. So I'm just welding the ends. The ends are going to end up getting cut off anyways, and that's where the MIG is going to live. Now I'm only welding the end. I'm not welding the sides of the faces. It's not necessary, especially as long as your material is at least 1/4 of an inch thicker, you don't have to worry about it bowing. Now, if it was a 4-inch long bar stacked up, or several 4-inch long bar, or 4 feet long bar, even if it was an 8-inch long bar, then you might experience some bowing as that steel expands and heats up. But because it was only over a 3, just over, what is that, like a 3 5/8 length, that length to thickness ratio was not going to cause it to want to bow. So even if it was 6 inches long. But again, once you get to like 12 inches long or something like that, then your steel is probably gonna start bowing. But it's just on the ends. All right, I'm gonna pull this bar out. I'm gonna let it air cool now, and call it a day. I'm gonna actually on top of the forge. We'll do a flyover. How's that sound? Cut the gas real quick. So that is not a bubble in the steel, just in case you're worried about that. It's just forge scale developing on the outside. But this is our bar, probably just over 12 inches long, or about 12, yeah, about 12 inches long. So I'll be able to get at least 3 knives, if not 4 knives out of this. But that's it for now. We're gonna call it good. I just realized the welder was on this whole time. That's cool. Waste of energy. Turn that off. Yeah, that's all I got. Thank you guys. Appreciate all of you jumping in and joining me during this stream, even though I messed things up. Hopefully there's still something to take away and learn from my mistakes. I will come back with that other billet forged out, drawn out, and all that jazz so that we can make that original pattern that I was planning. And I am gonna make sure I draw up a thing for myself so that, actually, I just realized it'll also be handy dandy for you guys as well, so that you can see what the hell's going on as I'm forging things out. So, okay, thank you all. We'll talk to you again later. For the people in the Patreon, you will definitely I'll make sure that you guys are all getting the link for the next round. Let's see, it's 1:55. I might do another live stream today. We'll see. We'll see how forging. We'll see how it goes. I need to eat some lunch. My brain's not working. Anyways, all right. We'll talk to you guys later. Thank you and goodbye.